Hello, 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 everybody out there, all you math contest enthusiasts. We're going to be starting another math competition, another Euclid competition, in fact, the Euclid from 2005. And you might notice something different about me. You might have seen it coming if you've seen some of my other videos for the past few contest years. I am wearing my school champion medal. I wore that for the 2002 Pascal, the 2003 Cayley, those sorts of, all the years that I won a school medal. I wanted to show it off because some of you out there, you might be winning school medals too, and it's an amazing thing. It's an amazing feeling to get get it awarded to you. So yeah, I've got my Euclid contest medal here, and this is actually a very special year for me, 2005, because if you've seen my 2005 Fermat videos, which should have been uploaded before this one, I had a medal on there too. I won 2 medals this year because I was in 11th grade, so I was able to write the Fermat, but being on different days, I could also write the Euclid, and I got a school medal for both of them. So both the Euclid and the Fermat. The Fermat one is somewhere in this room. I can't remember where I stashed my medals. I keep my Pascal Cayley Fermat ones separate from my Euclid ones. So I won a school medal this year, for 2005, and also again my last year, 2006. I didn't win another Fermat that year because I was obviously in grade 11, so ineligible. But so I won 2 contests, 2 school champion 2 years in a row. This hadn't happened, or not 2 years in a row, for 2 contests in a single year. This hadn't happened to me. This is very special because my chief competition, who was a lovely friend named Lisa, she had just graduated. She was 2 years ahead of me, so she had finally graduated. She was always better than me at the Euclids, but she was gone, and I had no major competition, so the Euclid was mine for the taking. And we're going to go through this 2005 Euclid now. I'm going to have my medal on just for the first video, just for fun, and we can take a look here. So, standard Euclid affair. We have the short answers are indicated by the light bulb, full solution indicated by the hand writing on the piece of paper. So we need to justify everything to get full marks for those questions. Standard 2.5 hours, calculators are allowed, all that fun stuff. You can take a closer read of this. If you click the link in the description, you'll get a copy of this contest to try for yourself. And I do encourage you to stop, download it, at least try question 1 before proceeding with this video. Okay? I always try and encourage you guys to try these questions beforehand because you can really tell where your strengths are and where your weaknesses are. If you try it and then come back and see, oh, maybe I should have done that, that would have been faster. Or, oh, I got a better solution than he did. That sort of thing. Okay? But I'm going to assume that during my little speech there, you paused the video and downloaded a copy, and we can jump right in to question 1 together. So we got 2 light bulbs for A and B, and then C part we're going to have a written solution for. Okay, so 1A. If the point AA lies on the line 3x minus y is equal to 10, what is the value of A? Okay. Well, A is an x-coordinate and A is the y-coordinate. Let's just plug them in. If they lie on the line, then they have to satisfy this equation. And that'll give us a single equation in A that we can solve. So, 3A minus A is equal to 10. Well, on this side it just becomes 2A is equal to 10. Divide by 2 on both sides. And we get A is equal to 5. And no more really needs to be said about this. If you want to, it's a final answer style question, so all you really need to do is put 5 in the answer booklet. But here's a little bit of justification. If you wanted a little more, you could write down what I'm about to say. AA is a point on the line, so it must satisfy the equation 3x minus y equals, so you can just explain it a little more, that sort of thing. Okay. That's a nice 1A. It should be quick. Just about everyone should get it if they actually want to be here writing the contest. I know that some schools make all the students write it, and I think that's a shame. Because not everyone wants to do a math contest. Maybe some people want to do a poetry slam. Who knows? All right, 1b. In the diagram, points A, B, and C lie on a line such that the length BC is twice the length AB. What are the coordinates of C? Okay. I don't know what the coordinates of C are, but I can give them names. I can call them X, Y. No reason not to. So let C have coordinates X, Y. So if we draw our picture, I want a little something like this. C, and then we had A was down here, and B, I don't remember exactly what their coordinates were. 0, -1, and 2, 0. Those are the coordinates of A and B. And we have C up here with X, Y. All right. So, there's a couple things we could do here. One that you would probably do is you could say, well, I can figure out the distance between A and B. There's this nice little distance formula. Distance is the difference in the x coordinates squared plus the difference in the y coordinates squared. And I can figure out this distance right here. We call it d. And then if I could double it here, I know the x and y coordinates for B, and I have stand-ins for the x and y coordinates for C. Maybe I can solve it and figure it all out there. Okay? That's certainly an approach, but it's going to give you a rather difficult time. But we're going to keep this d here. So we know that AB, we'll call it d. If we double it, we get the length BC. But we've got two lines here, the x-axis and our line that A, B, and C all lie on. That means that we're going to get the same angle here. What's more, if we drop this perpendicular down here, well, the x and y axes, they meet at a perpendicular angle. And that means that we're going to have two perpendiculars here, and then whatever this angle is, it's going to have to be the same, because the sum of the three angles in a triangle has to be 180 degrees. And so we're going to find that we have similar triangles. So we'll call this point O for the origin and D. Okay. And we're going to notice that triangle AOB is similar to triangle CDB. So if they're similar, that means that there is some common ratio between the sides. So I notice I have two hypotenuses here, these D's, which means that all the side lengths here are going to be doubled. So this length here, we double it, and we get this length here. So AO, so we'll just explain this. So since BC is 2AB, we note that CD is going to have to be twice AO. But of course, that's a distance of 1. But CD is our y coordinate. So y is going to be 2. Okay, fantastic. We already have our y coordinate. What else can we see? Okay, BD is going to have to be twice OB. But OB, of course, is 2. The x-coordinate here is 2, so we're going to have twice 2. That's 4. Now, x isn't BD. Some people might have put 4, 2 as the coordinates for C. That is incorrect. So this is 4 here. But we also have this distance of 2 here. So it's going to be OB plus BD. That's going to be 2 plus 4, 6. So C has coordinates of 6, 2. All right. I think that's a much nicer way of doing it than using the distance formula, which introduces quadratics and can make the question a little harder. If you did it that way, that's great. If that's something that you're accustomed to using, you're very good at manipulating that equation, you probably did it as fast or even faster than me. But I would say that for the beginner, similar triangle method would probably be the easiest thing to do. Okay? And maybe you didn't spot it, but maybe the next time there's a similar triangle question, now you will spot it, having seen me do it. Alright, so that's B. We were able to work out the coordinates of C. And now we've got C part, that's a written style question, even though we've been justifying all our answers as we go along. In the diagram, triangles AOB and CDB are right angled, and M is the midpoint of AC. What are the coordinates of M? Okay. So the first thing I notice is that we have a midpoint. We're asked for the coordinates of the midpoint. And the coordinates of a midpoint are just the average of the coordinates of the endpoints. So if I knew the coordinates of A, and I knew the coordinates of C, I could average the x-coordinates to get the x-coordinate of M, and I could average the y-coordinates to get the y-coordinates of M. So that's something I'm going to keep in mind. I want the coordinates of M as a midpoint. That's a plan of attack. So I've changed my problem from finding the midpoint, the coordinates of our midpoint M, into can I now find the coordinates of A and C? Okay. Well, A, right off the bat, it's going to have an x-coordinate of 0. It lies right above the origin. And it's part of a right-angled triangle, as they said. And we know some of the side lengths. So we could probably figure out AO as the other side length. And that's going to give us the y-coordinate of A. So let's jump back to our notepad. And we're going to work this out. So let's draw ourselves the picture. B, O, A, D, C, and M here. We've got 50, 50, 48, and I think it was 40. We'll just double check that in a moment. Yeah, 40. Okay. So, let's just jump right into it by Pythagoras, or by the Pythagorean theorem, the Pythagorean results concerning right-angled triangles, whatever you want to say. We know that AO squared plus OB squared is equal to AB squared. And we also know, just doing them both at the same time, BD squared plus DC squared is equal to BC squared. Let's call those 1 and 2. So if we want to work on 1, whatever AO is, if I square it, OB is 40 and AB is 50. So AO squared, we have 1600 here and 2500. We rearrange. Get AO squared is 900. AO is going to be 30. So A is going to have coordinates of 0, 30. Well, I wanted the coordinates of A. I also want the coordinates of C, and we're going to get to that in a moment, because then I can figure out the coordinates of M, and that's what I have to keep in mind. What am I looking for? The coordinates of M. as an intermediate step, we work out the coordinates of A and C. So now for 2 here, the one that we want is DC. We want this height here, because that'll tell us the y-coordinate of C, for example. Won't give us the x-coordinate. For the x-coordinate, we'll have to do 40 plus 48, but we'll get to that in a moment. So BD, we know what that one is. That's 48 squared. Plus CD squared is equal to 50 squared. Off the top of my head, I don't remember what that is, but calculators are allowed. So let's bring it right out. 48 squared. Yes. 2304. And then this should be 14. It's a 24, 7, and 25 triangle, so this should be 14, but let's work it out anyway. So we'll bring all the constants over to one side, and we get 196 over here. Well, 196 is just 14 squared, so square root both sides, we get 14. So C has a y-coordinate of 14, because it's directly above D, and D lies on the x-axis. And we have an x-coordinate of 40 plus 48. I don't think that really needs to be justified all that much. It's kind of clear from the picture. But that's going to be 88. Okay. So just to recap, we have our intermediate goal of A is at 0, 30, and C is at 88, 14. So N is the midpoint of AC. So we get its coordinates by averaging. 0 plus 88 all over 2. 30 plus 14 all over 2. That's going to be 88 over 2. 44 all over 2. And that's 44, 22. And if we wanted to, we could make a little final statement. Therefore, M has coordinates 44, 22. Alright, so that sums it up nicely. And that finishes off C part on question 1. In the next video, we're going to take a look at question number 2. It also has 3 parts: final answer, written solution. And hopefully you guys will join me for that one. Question number 2 on the 2005 Euclid.